In this video, I'm going to be building a portable 3D printer from start to finish. This printer is the JourneyMaker variant of Positron. For those that are not familiar with this project, Positron is an upside-down foldable 3D printer that can fit into a filament box, but also still being an awesome printer with high-quality printing capabilities. If you are interested in building your own Positron printer, you can find the custom part kit on voxelite.com. This video is not intended to be a build tutorial, but more or less an overview of the build process. This variant of the Positron printer has a full comprehensive build guide taking you step by step through the entire assembly, making it very easy to DIY at home. Without further ado, let's get right into this build. Starting off this project, I 3D printed the parts out of ABS filament. I ended up switching out some of the parts later on to add a color variant to this build. The first step in this build is using a soldering iron to fuse the threaded inserts with the 3D printed parts. The inserts allow for a reliable and reusable thread in the plastic. When using threaded inserts, it's important not to force them into the part, but rather allow the heat to slowly melt them into place. Moving on, I soldered the header pins onto my Raspberry Pi and shortened the motor shafts to the desired length. To cut the shafts, a member in our Discord community designed a printed part used as a guide to gauge the correct length. To cut the shafts, I used a hand saw that I bought from a local hardware store. I finished the rest of the cutting off camera as it took a bit of time. Now that all the prep work has been done, I can start the first part of actually building this printer. For this Positron variant, it uses a modified hummingbird extruder, originally designed as a mod for boron printers. Once completed, I tested the gears to make sure that everything was moving smoothly. Moving on to the Z-axis assembly, with this version of the Positron printer, the design utilizes a 4mm lead screw instead of the original belt-driven design from the Positron V3 by Kralin. Not only does the lead screw provide higher precision and accuracy, it greatly simplifies the assembly and part count. This brings us to the sponsor of today's video, PCBWay. PCBWay offers high quality and reliable PCB prototyping with fast delivery. PCBWay has sent me the boards needed to assemble the edge connector, which is an upgrade to the Positron bed design mentioned in my last video. Furthermore, PCBWay also offers more than just PCB manufacturing. They have CNC machining, 3D printing, sheet metal fabrication, and injection molding. If you are working on a project of your own, PCBWay has you covered for whatever your needs are. Click the link in the description below. One major improvement to this printer is the edge connector design for the heated bed. Just like any other FDM 3D printer, the print bed must be heated for proper adhesion. To aid the assembly process, I used two M3x8 bolts with nuts to align and hold the boards together. I then used my soldering iron to fill the solder pads, welding the boards together and creating an electrical connection. Incorporated into the design of a portable 3D printer, the bed is made detachable, enabling the ability to fold. In the original Positron design, a magnetic connector with pogo pins was used. This had many problems with the connection reliability and assembly being the biggest pain point. With this design, using an edge connector and two PCBs soldered together, the assembly is significantly improved. An important note when building this printer is to clip the pins on the edge connector after soldering. Otherwise, the board will short with the carriage on the Z-axis. Big thanks to Sample Names from the Positron community for inventing this edge connector design. The extruder is then mounted onto the side of the linear extrusion of the Z-axis and fixed in place with M4 bolts. The next sub-assembly I begin to work on is the tool head. Starting with the 90-degree hot end, I screw together the heat block, brass insert, nozzle, and heat break, inserting the heated cartridge as well. Off camera, I used a separate 24-volt power supply and allowed the hot end to heat for about a minute. I then hot tightened the assembly to get the best seal to prevent leaking. In this video, I also didn't show the assembly of the heatsink fan because I forgot to order this, and later on I added it into the assembly. Later in this video, I switched out the tool head for a modded version that utilizes the micro probe instead of the IR probe for leveling. This printer uses a 3mm GT2 belt for its inverted H-bot gantry. To use the 3mm belt, a custom pulley was designed using washers and two types of bearings. Here I'm using the wrong size washer, so to improvise, I added a smaller washer to go inside the pulley to correct the spacing. This ended up working out just fine. To build the custom pulleys, two washers are used with a flanged bearing. The first half is inserted into a larger pulley, and on the other side it is mirrored. I assembled a total of 10 pulleys. The NEMA 17 pancake motors come without any connections. To add the JHST connections, I crimped the motor wires. For those that have never crimped before, I'll give a brief tutorial. Off camera, I stripped a very small end of each wire. Then I inserted the female crimp connection into the crimping tool with the flap of the crimp facing upwards and resting it against the edge of the crimp teeth. I lock it into place and squeeze the tool all the way down once the wire is inserted. I did this for all three motors with the exception of the extruder as it comes pre-crimped. After all the wires are crimped, I inserted the wires into the connector in the correct order. The flap of the crimp will lock into place on the connector. Now that the motors are ready, I begin the assembly for the motor brackets. For each of the motors, I insert a gear pulley. The pulleys are then locked into place using two set screws. These two motors will drive the belt using a Core XY configuration. I place the motor brackets onto the motor and fasten them together using M3 bolts. Two of the pulleys that I made from before are also attached. I mirror this assembly for the left motor. The Z-axis motor is next, following a similar assembly process. A bracket is then inserted and a pulley with an arm is used for the belt tensioner. This is for the GT2 6mm belt that drives the lead screw. Now we begin the main assembly of this printer. I start off by placing rubber feet onto the base plate. You can see that there is some weird spots on this plate. That is because I did a really bad paint job. I tried to cover the holes, preventing the threads from filling with paint, but ended up causing this weird puddle look. But oh well, no one's really going to see the bottom of the printer anyways, so I think it's fine. Next I soldered the C6 outlet with the wiring connections for the power supply. When inserting into the side panel, it makes this very satisfying click sound.
Nice.
One of the more daunting steps in this printer is the power supply connections. I begin by soldering the outlet wires onto the AC input joints on the bottom of the power supply. On the other side, the same is done for the 24-volt output that leads to the SKR Pico controller board. This is to be done with extreme caution, so make sure to follow the steps in the build guide and check your connections before powering on. Duct tape is then placed under the board for added electrical protection. The base plate is also anodized aluminum. The two chassis cooling fans are joined together as the board only accommodates a single connection. I also skipped the step of inserting the side panels on the base plate, but for that I just inserted the bolts through the base and into the printed parts. The fans are fastened into the side panels. I make sure that the fan wiring goes under the X rails and the center panel. The X and Y motors assemblies are inserted into the printer. The Z-axis motor follows. Part of the bracket covers the exposed pins on the power supply unit. It is fixed in place from the bottom side. The power supply is also fixed from underneath, mounting into the side panels and Z motor bracket. The SKR Pico and Raspberry Pi are the controllers for this printer. It is inserted into the right side of the printer and once again fixed from the bottom side. Two sets of pulleys are stacked together with a spacer in between and are inserted into the carriage of the X rail. The Y rail follows with a pulley being mounted onto each end of the rail. The Y rail is then placed on a spacer that goes on the X rail, fastened with two bolts. This then creates the inverted H-bot gantry. Wiring of this printer is the final major step in this build. For me, this took up the most amount of time. I used a cable sleeve to enclose the wires of the toolhead, extruder, and bed connection. All connections are plugged into the SKR Pico using the wiring drawings that can be found in the build guide. The belt is routed around the pulleys and fastened into a belt clip and attached to the tool head. The belt isn't too bad to assemble, and once again there is a full guide step by step for this. I then insert the tool head, check to make sure the motion works, and adjust the belt tensioner. At this point, the only thing left is to cover up the printer with the top plates. After that, I insert the first thumb screw into the back of the Z-axis and lock the belt tensioner arm into place. The second thumb screw is bolted down onto the bed holder and the bed is inserted into the edge connector. And just like that, the printer is complete and ready to go. This build took me roughly 5 hours to complete, and I did it all in one sitting. Earlier in this video, I mentioned that the toolhead was swapped out for a modded version. This one utilizes the BealTouch MicroProbe V2. Here we can see it in action. This sensor is far more accurate and reliable than the original IR probe. This modded toolhead also has an accelerometer for input shaping. In the last video, I talked about the bond between the glass and the printed part. A lot of people are worried that the print might fall off. It can be observed that while the bed is still heated, it is rather difficult to pull the part off. When cooled down, the part will come off with ease. And that is it for this video. If you're interested in more about this printer, come join our Discord community where myself and others are actively developing and supporting this project. Link to that is in the description below. Thanks for watching.